Hi, I'm going to look at a problem like the homework problems number 5 and 6, where we talk about critical values. Let me just kind of go back on a few things here before I do that. Okay, so from your PowerPoint and also from the videos in MyMathLab, they talked about critical regions, critical values. We talked about how to tell if it's two-tailed, left-tailed, or right-tailed. Again, we look at the alternative hypothesis sign. I'm just going to kind of zoom in here so you can see it better. Okay, so if the alternative is not equal to, that means you have two tails. If it's less than, you have one tail. And if it's greater than, you have a tail on the right. So in this case, you're going to actually have two critical values. One's going to be negative, one's going to be positive, because zero's in the middle when you talk about standard normal. If it's left-tailed, your critical values could be the number right that goes right here. That separates the rejection region from the non-rejection region. So your critical value would be negative. And if your alternative hypothesis is greater than, then this is your rejection or critical region, so your critical values can be positive. Okay, so going back to this problem, we're going to go through the first three steps. The first three steps I've covered in a couple of different videos. We're going to go through these first three steps, and then we'll decide whether it's left-tailed, right-tailed, or two-tailed. And then we'll actually jump down to here we find the critical value and we make our decision. So we're not doing the middle part, we're just doing the first three steps and then step 6 and step 7. Okay, using the critical value method. Okay, so first of all, here's my claim. So step 1 on the sheet right here is put the claim in symbolic form, so that's the first step. Step 2 is to write down the opposite, or what must be true when that's false, and that would be greater than or equal to 0.76. Step 3, you find the null in the alternative. The null always has the equal sign. The alternative will be an inequality sign. It could be either one of these that doesn't have the equal sign, so it's automatically this one, because this one has the equal sign. So this is my alternative. And my null is always equal. Okay, so those are the first three steps. And by looking at this, I could tell that's a left-tailed test. Okay, so what I'm going to do is I'm going to go ahead and draw a left-tailed test. So I'm going to show you what that looks like again. So a left-tailed test will look like this right here. So I'm going to draw a picture like this, and I'm going to shade the left side. This is something that we'll get into more commonly in the next couple of sections. It's a left-tailed test. This area of the tail is actually equal to alpha, which they told me right here is 0.05. So this is my alpha. So when it's left-tailed, it's just 0.05. If it's right-tailed, it's 0.05. If it's two-tailed, you're going to take that and divide by 2. That would be another homework problem. So what we want to do is we want to find this number right here. This is what we call the critical value. Okay, we assume this is a stair normal. So we're going to use inverse norm. And remember from chapter 6, you put the area left, which is actually this. The mean and the standard deviation. So you put inverse norm, area to the left, the mean, the standard deviation, which for standard normal would be 0, 1. And if you go ahead and plug that in, you should get about negative 1.65. Okay, so that's my critical value. Okay. So what we're going to do in the future sections is you're going to compare the test statistic with this. Here's our test statistic. If the test statistic falls in the tail, remember there's a 0 right here. So right here is negative 1.65. I'm just going to add that right here. A different darker color. So if my test statistic falls in this region, I'm going to reject the null. If not, I'm going to fail to reject the null. Okay, so to explain that more, I'm just going to show you that one sheet that has all the documents and all the information here. It says reject the null if the test statistic falls in the critical region, which means it falls in your tail. Fail to reject if it does not. So your critical region is basically your tail. So if I look at my test statistic is negative 2.86. That would be over here more to the left. So it does actually fall in the critical region, so I am going to reject the null. Okay, now we have to decide which one do we pick. Okay, there's a flow chart that we'll cover a little bit later that kind of helps with this part, but before we do that, I'm just going to show you kind of the old-fashioned way to do it. This is my null, and I just rejected it. So when I reject the null, I'm saying that's wrong. I reject that, therefore I assume this is true. And this is actually the claim. So when I reject the null, I'm saying that their claim is correct. So whenever you reject null, it should say there is sufficient. So that's another hint. Whenever they say reject, usually they say there is sufficient. When you fail to reject the null, usually say there is not sufficient. Okay, so in this case, if I reject null, I'm going to say there is sufficient evidence to support the claim that P is less than 0.6. So again, I rejected the null. So when I reject null, I say this is wrong, this is correct. And that was their claim. So I'm saying their claim is correct. Okay, so this is number 6. I think there's another number 5 as well. It may not be left-tailed, it may be right-tailed or two tails, so just kind of remember if it's right-tailed, your critical value is going to be positive. Left-tailed, your critical value is going to be negative. And if it's two-tailed, you're going to take your alpha, divide by 2, and you're going to have a negative and a positive of the same number.